Hey folks, Will18 here, and welcome to another episode of our Unity 3D tutorial on how to make a multiplayer first-person shooter. Now, in the last episode, we actually got our networking to be technically working. We can have more than one player connected to our server, we can move around, and when we move, we only control our player, and the other players see us moving. The problem is that the players see us moving in a very shaky and jittery fashion. And why is it? Well, there's a few reasons. The thing is, when our player moves, okay, the transform changes, and this photon view is observing this transform, and every time the transform changes, it sends out that information to the server, which then reflects the information back to all the other players and tells them, oh, I am no longer positioned here, I am now here. Now, that only happens so fast, and the reason is there is latency on the internet. It takes a while, even for me running two copies on the same computer, it takes a while for the signal to come from game number one to go all the way to the Photon server, then turn back around and come all the way back to me to my other game instance. And to make that round trip, there's a little bit of delay. And then what happens is, this Photon view simply says, okay, you were here. Now I just got an update that says that you were here, so I'm just going to change the transform to say that you are here. So our guy is teleporting from here, boom, to there, boom. So the guy will sort of blink very jerkily from one place to another. Also, there's a little bit of jitter, especially with the jump, because what's happening is the character is jumping in the air. Now the character has a character motor script still running on his system. So in the air here, the character motor is saying, well, I got to drop you a little bit, and sort of starts to drop, and then the next Photon view update comes in and says, oh no, you're not quite there, you're slightly in a different position than you thought. So there's this weird sync issue. One of the things we actually could do is just turn off the character motor script on our network players and let them simply have their movement synchronized by the Photon view script. In fact, that's quite interesting. Let's give that a try, shall we? So I'm actually going to go into my scripts controller here, the network manager. I'm going to reopen this. And I think that means I got to bring the font up again. Yes, I do. It's very interesting. Let's try that. Curious. So I'm going to go into players, player controller. Our character motor we've now turned off by default. So obviously we now have to turn that on for our actual local player. So remote players have basically nothing existing on their script anymore. Hell, we could even turn off the character controller, although at this point it doesn't really matter. The only way that our remote players are going to be moving on our screen is when they get updated by the Photon view. And that should actually work. And in fact, it'll smooth out, it'll get rid of the jitter effect on the jumping. Because I realized the jitter on the jumping was being caused by the character motor sort of trying to update the character in potentially an inappropriate fashion. Inappropriate for our server. So again, here we can still move, which is great. And then we can start a second instance over here. And we can move, which is great. Let me grab this guy. There it is. There's the bridge. There we are. I'm going to move up to the top of the bridge, and on this view I want to just bring it so that actually, let's do the thing where we maximize again and maybe get a little bit closer like so. And now I'm going to tab back out over here, and on this view I'm going to jump. There we go. So now we don't get the back and forth jitter because the character motor is not fighting the Photon view update script. But you can still see we're still just sort of teleporting. It looks like it's bad frame rates over here, and the reason is between latency and also the fact that the Photon view doesn't literally update the server as often as possible. It runs updates every 10 or 20 times a second, something like that. So there's going to be a limit, because the problem is it makes no sense. It makes no sense to send network updates 100 times a second. It takes longer than that for a freaking packet to get to the other computer, so it's pointless. So this jitter is there because it's in one place, and then it's instantly in another place, and then it's instantly in another place without a smooth motion in between. Again, we're running this, hundreds of frames per second. We should actually get a nice smooth transition from one screen to the other. So let's go and put that in. And you'll notice now in this world, the other character went away. It was automatically cleaned up when I left the game on this side, which is wonderful and beautiful. Okay, so what are we going to do? This Photon view, instead of reading the transform directly, we're going to have it observe a script, and we're going to use a script to change the way that the movement is updated. Basically, we're going to smooth it. Instead of directly teleporting from one position to another, we're going to slowly move from one to the other over time. And by slowly, I mean, still in a fraction of a second, but slower than instantaneous. Now, depending on how you have your things set up, you could change the observed script to just your character motor. that works. In fact, that potentially works very, very well. What is it called? Player controller. Oh, because that's the name of the object, but we are observing the character motor script. And that might work. The reason I'm not going to do that today, and that's normally what I do, is my character motor script. That's the thing that I sync, and then I do some special code in here to make it work properly. The reason I don't want to do that is because this script is JavaScript. Ugh, and I hate working in JavaScript. It's just a stupid, big, stupid mess of stupid. And there's little silliness like what's happening over here and whatever. I'd rather just write my own script. Plus, this character motor script is actually relatively complex. There's a lot of stuff going on. We're using it because it's saving time, not because it's necessarily making our life much simpler. So we're going to leave the character motor script turned off on objects that are updating over the network, and instead we're going to create something called, we're going to create network character. Boom. In C#. And so this will be turned on by default, which actually means that when we connect on our particular player, we want this turned off. Network character dot enabled equals false. No, that's not true at all. Oh, I'm lying. Okay. The reason we can't turn it off is because on our view, network character is going to be responsible for sending out our position data. And then on everyone else's view, it's going to be responsible for accepting the position data and updating their own position. So let's open this bad boy up. So there's a lot of stuff we may or may not need. More or less leave it in there. What we need is a new function, though. We need a function called... does it have to be a public? It may have to be public. It's not going to hurt if it's public, so... No, it doesn't have to be public. Well, we're going to find out. We're going to leave it like this, and we might get an error. Photon serialize view. And it gets past two things. It gets past a Photon stream, and it gets past a Photon message info. What the hell is going on? Well, it's easiest to explain by literally writing a little bit of code. If that, we can go if stream dot is writing. Whoa. Wow, I made the same typo twice? That's amazing. If stream dot is writing, do something else. Do something else. What does this mean? This is our player. We need to send our actual position to the network. And then the else is, this is someone else's player. We need to receive their position as of a few milliseconds ago and update our version of that player. Okay? Clear as mud, as people like to say. So what are we going to do? Well, to start off with, it's going to be very, very simple. On our player, we're going to take our stream, we're going to send some data, and we're going to send it, well, where we are, transform.position, and we're also going to tell it, send next, transform.rotation. Here's where we are, here's where we're facing. And then on the other side, we're going to say, okay, all right, transform.position. We're going to update it from the stream. We can do stream.receive next. But the thing is, receive next just receives, this is a generic object thing. We've got to cast it. We need to know, we know that this is a vector 3. So we have to tell the system, by the way, this is a vector 3. Okay, we can do it this way, or we can do it as vector 3, however you prefer. I'm kind of an old school C-type person, so I like to cast like this. So we're going to do that, and then we're also going to update our rotation, because we know that's the next thing that comes in. Rotation is a quaternion, so we're going to do that. And, all right, we're just going to leave it off like this for now. We're going to do this exactly. So network character will always be enabled on all player characters, on all player controller objects, right over here. It's got the network controller. If it's ours, it's going to do this thing. If it's someone else's, it's doing this thing. So if I hit, if I build and run the game, and there's going to be a little bit of delay when we get this started. We got to wait for this cutscene to go, and I'm going to go wait for this client to actually create the room for us. If I hit play too fast on the other thing, both players will be in their own rooms, because it's possible if you join too fast, they're each going to try to join a random room, fail, and then they're both going to try to create their own room, and they'll both be in their own private rooms, and it'll look like the system didn't work, even though that it is. So, having done that, where's the other player? There he is. Hello. So I'm going to keep an eye on you in the corner, and now over here, I'm going to look around. Oh, the updates are not actually working. Really? What did I do wrong? As you can see, I don't know. Oh, there, right there. So this guy, they spawn in the same place, but on my actual, on this screen, I have jumped off the ledge and fallen next to here. But here, the guy is still up there. And in fact, my player 2 in this window has moved as well, but this player is not aware of that. So, what did I mess up? Is it supposed to be a public? Let's find out. It might be as simple as that. Quoi? Oh, this is still running. Like, I can't build a new version of the exe because there's a file there that I can't delete first. Alright, let's find out if that fixes it. If it doesn't, I'm gonna look pretty dumb on camera here. Alright, connect up. Let's go up to the bridge. Let's connect up over here. While that's still connecting, we're gonna move along. Alright. Shoot. Alright, let's figure this out. First of all, is this running? Debug.log. If I run this here, my console log should just be filled with spam. Okay, yeah, we're disabling the camera though. Oh, I'm not, hold on. Let's get rid of this annoying error. First of all, in our network manager script, we're disabling the actual camera, but not the audio listener that's on this camera, and it makes no sense to have more than one audio listener, so it's legitimately complaining. Here, instead of grabbing the camera, let's just grab the actual game object of the standby camera. Alright, so I can drop that in there. No? No, yeah, because it's an error. Because the standby camera here, we don't want to enable because this is not something you can do. Instead, you go set active to false. So now this script should render. And now this will require a different type of object because it used to take the camera component, right? This is a camera component. So that used to be what was in that slot, but you can't do that anymore. It wants a game object, so we're going to grab the game object in there. So now when we start the game, it'll disable that whole object, including the the audio listener there. So we got rid of that error, and it's clearly not running on Photon serialized view. First, let me double check that I haven't actually typoed anything, but I don't think I have. No, that's definitely not a typo. Resources, player controller. Ah! We're not observing the right thing. So that serialized view is never being run here because we're observing the character motor, which is not what we want. We want to observe the network character object. There we go. Oh, that's not good. Any changes you make while you're playing will not be saved, so we got to drag that again. There we go. Network controller, save, play. And again, we should get spammed like crazy here. Is it because there's not another... Oh, whoa, what happened here? It might be because we don't have two people in here. Doesn't feel like that should be the case. I hate it when you find an error, you're like, oh, that's what it was, and then it still doesn't fix it, and you're like, okay, so I had multiple errors. That's great. I love my life so much. All right, we have joined. Good. Go over here. Oh, there we go. Yeah, it's because we didn't have 2 players. So now if I pop back over here, and I somehow get everything working. You know what? I'm going to move it to my other monitor. You should see this guy move around. There we go. Look at that. So now I'm moving on my other screen here. Hello. I can even jump. There we go. Good. Okay. Whew. Huge, huge relief. Now, we still have jerky vision. And the reason we still have jerky vision, let's get rid of this debug log because that's just way too much spam, is because this update, the way this update is working, is pretty much exactly the same as just watching the transform directly. Doing this, observing the transform, what this does is pretty much these 4 lines of text, or 6 lines of text. I don't know, comments, white space, blah, blah, blah. It's pretty much exactly the same. So just because we are now observing this network character, we're not doing better. The thing we want to do is we don't want to instantly update the position here. We don't want to do that at all. We want to update it slightly, right? We've talked about that. So what we want to do is actually save it. This is only something that's going to affect us if it's not our object. So let's do something really quick. Instead of using the normal mono behavior, because what we're going to want to do is we need to be able to find out in our update, we need to find out, is this my player or is this someone else's player on the network? We know that here because we can check to see if we're writing to this stream or reading from it, right? We are only writing to the stream if it's our player. If we're reading from it, we know it's someone else's player that's on the server. But in our update, how do we tell if it's our player or not? Well, there is an easy way, and it involves, we have a Photon view component right here, right? So I could do something like get component, Photon view, right? I have a Photon view on my object, and then there's something called is mine. That's it, it's a Boolean, is mine. If this object is mine, do something, otherwise do something else. I can do that. The other thing I can do, and obviously I can cache this, right? I can do a Photon view, and then Photon view equals that, right? I can totally keep this thing around and do it in my start. I can actually save a little bit of time. The Photon network dot mono behavior. Photon network has its own version of mono behavior. It's exact same mono behavior. They just added some stuff to it. And one of the things they added is a shortcut to, why is this not working? Recompile, make sure everything is okay. Clear. Sorry, is it Photon dot mono behavior? There it is, Photon.mono behavior. And now we have a built-in Photon view on our object. And a couple of little extra things for convenience sake that just make life easier. So we're going to do that as a shortcut. But you don't necessarily have to. It's just nice. All right, Photon view dot is mine. Okay, I'm going to wrap this. Honestly, if it's mine, do nothing. The character, motor, input, etc. is moving us, right? The question is, if it's not ours, what do we want to do? That's what we want to do. And what we want to do is a smooth movement here. So what we're going to do is we're going to create vector 3. We're going to call it real position. And we're going to create a quaternion called real rotation. All right, I guess we can initialize these to 0. I guess they start off by being 0, but equals quaternion dot identity. Okay? And what do we want to do? So here, we want to actually just grab the real position and the real rotation. We want to grab that stuff right in here. And then in our update, what we want to do is our transform.position. We want it to be equal to, we want to do a lerp. Vector3.lerp from where we think we are to where we actually should be. And then we want to give it a certain amount of time. And what I'm going to do is I'm just going to put in a number. This is going to be like the sort of general smoothing speed, how quickly it teleports us from one place to another. And gosh, there's a lot of different ways to handle this. Ideally, we would want to have the movement from one to the other be equal to the amount of time since the last update. But what we can do here, and we may do that. For now, I'm just going to put in a value of this. On every frame, we're going to move half the distance. Is that right? No, I don't want to do that. I want to do something like, maybe we actually will log the time. Float last update time. So, what can we do? I don't want to overcomplicate things. Let's leave this out for later. We will look in this later. Literally every frame, actually every visual frame will just get 10% closer. We actually run these frames very frequently, so this will happen very fast. We may actually want to do it on a fixed update, but this is going to be totally okay. So we're going to move from where we currently think we are to the real position. We're going to update our position here, and it'll pretty quickly update. And we can do the same thing with our rotation, because we can do transform dot rotation, because the quaternions also have a lerp. So we're going to take our where we think we are, where we should be, and again, we'll go sort of 10% closer every time here. And this is not going to be terribly sexy, but it's going to work. There's also this first update is going to be kind of wonky, but we're going to deal with that in just a second. So let's go ahead and... Is that not the hotkey? Why is Control B not actually working for me? I'm going to build this. Connect up. Wait, you know what I should do? Is I should... Whoops, that's not what I meant to do at all. I'm going to say I want to just flip these two around, so that way my game is on the left and it's just easier to fit both in there. Good, there we go. That's smarter. Just waiting for the extra character to come in. There we go. So now... Oh, that's... Frankly, that may be good enough. Visually, it's a nice, smooth transition from one spot to the other. Like that. I don't know what it looks like on YouTube, but on my screen, it looks perfectly smooth. We may not have to get any fancier than this at all. And we can. There's all sorts of things, right? What you could do in your player, and I've done this before, and frankly, I've probably just overcomplicated my life. In the player, I may have done the serialize as part of the motor script, and I didn't just send, this was a thing recently with one of the space things, I didn't just send my current position and rotation, I also sent along my current velocity. That way, over here, what I could do, in addition to lerping sort of position, I could also add in my velocity, my velocity times time.delta time, which meant that it could sort of, this is weird, but yeah, it could sort of predict where I was supposed to go next and try to be all smart and all that. And for some games, for a racing game, perhaps you might need to be a little bit more precise and exacting. Flying games, anything where there's huge amounts of speed involved, then you may actually have to be a little bit more predictive. But then these functions start to become a little bit more complex. It turns out that just slowly lerping from one spot to the other smooths it out pretty goddamn good for our game, so we're going to leave it be and not make our lives any harder than this. We have a sexy looking game all of a sudden, and I'm feeling pretty happy about it. And in fact, that went so much easier that this episode is going to be slightly shorter than I meant to, but I want to put a cut in here anyway. See you next time, folks. Bye-bye.